Welcome to the first class of CAT 21. We are here, we're gonna talk about the different parts of CAT. So let's say if I talk about a CAT, the paper normally gets divided between verbal, then you have quant, and then you have LRDI. Now between these, today we're gonna talk about the first topic of quant, and the first topic in quant is numbers. So what we'll do in the next few minutes is we'll talk about what all comes in numbers, and in fact we'll start with the first topic within numbers, first subtopic of numbers. Now to start with that, let's say we first of all will talk about a number tree. A number tree is basically that you divide the numbers into two parts. The first part is the rational numbers, and the second one is irrational numbers. Now, what is the difference between a rational and irrational number? If you go back and if you talk about when we used to be in class and we used to, a teacher used to ask us, what is a irrational number? What is a rational number? There was one definition which we have just crammed it. Every time the teacher used to ask about it, we used to say, any number which can be represented in a p by q form is a rational number. So you simply say anything which could be represented in a p by q form where q is not equal to 0 becomes our rational number. And any number which is not rational, that's so simple, right? Any number which is not rational is an irrational number. So what's the difference? So simply a number can be represented as p by q is a rational number. Any number which cannot be represented in a p by q form is an irrational number. So for an example, let's take 7. Now if you ask me what is 7, 7 is a rational or a irrational. So you simply write it as 7 by 1. So when you write it as 7 by 1, it becomes a rational number. While if we take at the same time, if I take something like a pi, 3.14 and so on. Now, though we say that, pi, we have a value as 22 by 7, but this 22 by 7 is not a value of a pi. It's an approximated value of pi. Approximated says you have got it as 22 by 7, but actually the number is never 22 by 7. So a better way to detect whether a number is a rational or irrational is simply by saying that it can form a p by q form. Now what you can also do in here is for finding out whether the number is irrational, so what you can do is any number which has a surd over it. Now surd simply says either it's a square root or it's a cube root or it's a fourth root and so on, and it's not a perfect square obviously in case of a square root. So let's say if I write root of 7, it becomes an irrational number for me. While if I write 3 by 5, that's a rational number. Even if I write root of 49, because it's a perfect square, if you see 49 is a perfect square, it gives you 7. So it becomes a rational number for us. Now there are more ways to find out rational and irrational. We'll talk about it in a while, but let's first complete our number tree. So if we start with the number tree, we just started. And just one thing which I also want to mention, in fact, before we move on, that the first division is a real and imaginary number. Now, difference between a real and an imaginary number is very simple. If you remember your 11th and 12th, and that was a time when we used to face the major problem around the imaginary numbers, because I don't know about you, I never liked actually the complex numbers as a chapter. So there are some of you who might at that point of time might have not liked imaginary numbers. So the good piece for you is CAT doesn't ask about this. CAT can only ask you one question normally, which would be around iota. What is the value of iota? So the value of iota, whenever the CAT asks, you say it's a root of negative root. The root of -1 becomes your iota. That's it. We have to focus on the piece which is your real numbers. Now within a real number, the first bifurcation was what we just did, is a rational and a irrational numbers. So rational numbers and irrational numbers are your first bifurcation of a real numbers. So we have just understood what is a rational and what is a irrational number. Now if within a rational and a irrational, if I have to find out what is the further bifurcation for rational numbers, the rational numbers would be further divided into the integers and fractions, right? So we start with real imaginary, go to rational, irrational and integer fractions. So this is